Hi student, today we have a third lecture on the subject of general hygiene. The lecture will be read by head teacher of the Department of General Hygiene and Ecology, Baxışlı Fərəh. The topic of today's lecture you see on the screen. Water as environmental object, physiological, hygienic and epidemiological meaning of water, hygienic estimation and norms of water quality, methods of clearing and disinfection of water. Water is one of the most widespread natural compositions. The total amount of water consists of 1.5 billion cubic meters, approximately 94% in the seas and oceans. The big maintenance of salts, till 35 grams per liter, makes this water unsuitable for the economic drinking purposes. Fresh water makes less than 6% of all water reservoirs. The most part of water reservoirs of fresh water are contained in glaciers. Really, for the drinking purposes, 0.2 up to 0.35% of all water of the earth are used. More than 2 billion people need in good quality water. The reason: irregularity of distribution for the CIC, 80% of fresh water is concentrated on the Far East. In Siberia and European North, there 33% of the population live only. Development of cities, unlimited consumption of underground waters. For example, Mexico falls annually on 40 centimeters for pumping out of underground water. Increase of water consumption. Second, decrease of water quality as a result of population by microorganisms and chemical substance, a problem of water hungry. Reduction of water hungry is preservation of natural water's quality, is effective cleaning, rational use, development and use of accumulation reserve of fresh water in underground water burning horizons, use of glaciers, demineralization of the seas. The problem of water supply infringes interests of the big number of people. This factor follows from that role which water plays in human physiology. As is now, the human body consists of 65% of water. The organism, even in condition of the starvation, not satisfied thirst at absence of physical loading loses some of water which is formed in a result of continual oxidizing processes. Whereas a small water deficiency in the organism result in the considerable health infringements. In experiment, this animal, it is shown that water loss of 20–22% result in their death. All this speaks that process of digestion, synthesis of living substance in organism, and all metabolic reactions take place only in the water environment. Despite of extremely big physiological role of water, water expenses for the drinking purposes is insignificant. In conditions of a temperate climate, at absence of physical loading, the man loses 1.5 liters of water per day. On a consumption level of drinking water, influences natural temperature and humidity of air, isolation, wind, and social working condition factors. So, during physical average work in the temperate climate, it is necessarily 4 liters. At the same work in a hot climate, 5 liters for water per day. In unusual cases, at working condition of desert or in the hot shop, the water need for men can rise up to 11 liters per day. However, hygienic value of water is not only physiological role of one. A great deal is necessary for the sanitary and economic and domestic purposes. Water commercially promotes the development of hygienic skills, for example, body care, keeping in cleanness of household goods, etc. The sanitary condition of treatment and prophylactic establishments depend on quantity of consumed water. The rational centralized water supply is an important condition for prevention of hospital nosocomial infection. Water of drinking quality is necessary for creation of reduced sanitary engineering conditions at the enterprise of the food industry and catering with the purpose of the prevention food toxic infections and intoxications. Commercially, water is used for carrying out of improving and sport actions, for example, swimming pools, and hydrotherapeutical also. It is necessary to emphasize that for water consumption, there is a purpose of prophylaxis of infection diseases and improvements of the sanitary conditions of population's life is necessary the drinking water of corresponding quality. In the basis of norm of water consumption are put physiological need, body hygiene, preparation of food, cleanness of dwelling, water discharge in public institutions, for sprinkling, and etc. You can see the role of water in human life on this slide. In the countryside, at use of water from water folding columns, norm of water consumption are 30 up to 50 liters per day, and in city up to 40 up 400 maybe 500 liters per day. For example, in Baku, in St. Petersburg, for one person is spent more 700 liters. For example, in Moscow, for example. In Rome, in 1000 liters. It is a lot of fountains, reservoirs, is emphasizes aesthetic value of water as health growing factor. The water quantity which necessary for one inhabitant in day depends on the climate of place, a cultural level of the population, a degree of accomplishment of city and housing stock. On average, in Azerbaijan, water consumption makes more than 400 liters per day. In some cities, development of a water pipe allows to provide enough high norms of water consumption. On this slide on screen, you can see the physiological importance of water. The first, the presence of water in the composition of cells and tissues that determines their morphological properties. Second, it is a favorable medium for the physiological and biochemical processes. Third, as a universal solvent, is involved in the body minerals and nutrients. Fourth, provides the removal from the body of harmful products of metabolism. 5. Provides a course of redox reactions. 6. Participate in the heat exchange of the body. 7. Provide turgor of tissue. And last, 8. Provides water salts and water and electrolyte metabolism and acid-base balance in the body. On next slides, you can see hygienic value of water. What is the hygienic value? The first is keeping the body in proper cleanness. Hardening of the water through water treatment, bathing, hydromassage, rubbing with a damp towel, water sports, etc. Next is clearing of apartments, cooking food, washing dishes, clothes and laundry service, cleaning streets and squares, stores that demand appropriate cleanliness, create and safe grid space. Now, I want to talk about organoleptic properties of drinking water. What is the organoleptic and physical methods of water examination? Examination methods which use the sense organ to study some external or internal properties of the object is an organoleptic method. This method is prevailing in sanitary practice because it is not only simple, available, and not requiring any equipment, but also is very sensitive. It allows of determination this marginal change in water, air, and foodstuffs quality, which cannot be revealed by analytical methods. Hygienic requirements to quality of drinking water are regulated by working normative documents. For example, it is sanitary rules and norms drinking water. Hygienic requirements to water quality in the centralized water supply, quality control. It is a name of these rules. According to these requirements, the drinking water should have favorable organoleptic properties, should be colorless and transparent, without odor, flavor, and also should have refresh temperature. Be safe in epidemiological meaning, be safe in radiation meaning, be harmless in chemical composition, have favorable microbiological and parasitological parameters. What is a water analysis? Organoleptic methods are: second, determination of odor; second, determination of taste and smell; the third is determination of colority; and fourth is determination of water transparency and water turbidity. And next, maybe physical methods, determination of water temperature. Organoleptic property of drinking water should meet the requirements indicators in these slides. On these slides, on this you can see in this table. For example, indicator, you can see on this table indicators, units, and norms, highest value. For example, you can see 4 indicators: odor, taste, colority, turbidity, and highest value. It's norm of organoleptic indicators. One of the main principal questions of drinking water hygiene is the choice of a water source. This choice is carried out by technical and economical comparison of variants of water supply source, which can be atmospheric, underground, and superficial. Atmospheric waters, rather weak minerals that very soft, contain few organic substances, and are free from pathogenic bacteria. Certain methods of water gathering and storage influence on water quality. Underground water suitable for the purposes of drinking water supply are deposited on depths no more than 20 to 150 up to 300 meters. Next condition of water bedding are different. Upgrade water, underground waters, and middle waters considerably distinguished from each other by hygienic characteristics. The underground water deposits most close to Earth's surface are named upgrade waters. Upgrade water easily becomes dirty owing to superficial bedding, absence of a waterproof roof, and small volume. As a rule, in the sanitary relation, it is unreliable and cannot be considered as a good source of water supply. Subsoil waters are the waters of the first from a surface of the ground constantly existing water-burning horizon. They have not waterproof layers as protection. The feed area of subsoil waters considers this area of their distribution. Subsoil waters are characterized by the rather changeable regimen, which entirely depends on hydrometeorological factors, frequencies of loss, and an abundance of precipitations. There are significant seasonal fluctuations of a standing level, chemical and bacterial structure of subsoil water. The water reserves are replenished due to the infiltration of atmospheric precipitation of nature rivers water of a high level. In process infiltration, water is released from organic and bacterial pollution, thus improve its organoleptic properties also. Subsoil waters are used mainly in countrysides as the organization of well water supply. Middle waters are deposited between waterproof layers and, depending on bedding conditions, and can be pressure or not pressure. Middle waters differ from underground by low temperature, for example 5 up to 12 degree, structure stability. Usually they are transparent, colorless, devoid of smell and any smoke. Due to a long filtration and waterproof roof protecting middle waters from pollution, in it is almost absent microorganism, and this one can be used for drink. Middle waters are extracted with the help of deep tube well and less often mineshaft. Constant and big discharge of water supply source from 1 up to 200 meters and high qualities of water allow to consider middle horizons as the best source of water supply for small and average water pipers, majority of which give water to the population without any clearing. What is a spring? Underground waters can independently rise on a ground surface. In that case, they carry the name of springs. From them are formed cases of streamlets. Superficial waters flow down on natural slope, no more lowered places, forming flowing and landlocked reservoirs, streamlets, rivers, flowing and landlocked lakes. Open reservoirs are provided for not only atmospheric but partially underground waters. Open reservoirs are subject to pollution from the outside. Therefore, this is the epidemiological point of view. All open reservoirs are potentially dangerous. Water reservoirs near settlements are especially dirty due to the discharge of sewage. If necessary to use an open reservoirs for water supply, it is necessary to prefer, first, large and flowing reservoirs, second, protection reservoir for pollution by household and industrial sewage, and thirdly, it is necessary to disinfect water safety. Therefore, the underground waters are subsoil, groundwaters, interstratal non-artesian water, and interstratal pressure, or other names artesian waters. Subsoil waters, the current depths depend on local condition, making from 1 to up to 10 meters. Groundwater, the underground waters accumulate on the first waterproof layer from the surface of the ground, making from several meters. And last, interstratal waters are between two waterproof layers and therefore they are more protected against different kinds of pollution. The water supply of modern city and rural settlements should provide quality and quantity of drinking water appropriated to hygienic requirements, maintain the high level of public health, accepting risk of diseases transmitted by water. There are two systems of water supply. The first is centralized pipeline water and decentralized or local, which use without purification, especially in rural areas. Decentralized local system is a primitive, labor-intensive and hazardous to health in epidemic sense. It is presented by Manshaft and Horribilis. At the local water supply, the water is captured directly from source, a draw well, spring, borehole, without any processes. At the centralized water supply, the water is taken away from surface or underground water source mechanically, subjected to special processes, and is delivered under pressure by water people to place of utilization. Inspection of water supply source locally has a big practical meaning and should underlie in hygienic estimation of water quality. The laboratory analysis characterizes a condition of water at certain moment, but does not give complete overview about the water source and the reason of its pollution. Local inspection of water source allows to reveal possible pollutants of water, to find out how they are constants, to plan waves of further pollution prevention. The program of water source sanitary inspection include examination of water source in the field, were named sanitary topographical inspection, determination of water quality in a water source and its discharge, sampling of water for analysis, the survey of mobility among people and some kinds of animal in the areas closely located to water source. All chemical compounds incoming into human organism from environment divided on essential and non-essential or toxic substance. The chemical compound of organism is connected to a chemical compound of an Earth's crust. On the basis of Vernadsky doctrine, academic Vinogradov has created the doctrine about biochemical provinces. As a result of deficiency or surplus of one of the another element is developed endemic diseases. In the organism, macroelements applicably comes with water. For macroelements, it is not the basis way of receiving. In total, in human organism, was determined more than 80 chemical elements, which can be subdivided on macro, micro, and ultra-macroelements. Macroelements, they are carbon, oxygen, hydrogen, azote, calcium, magnesium, and others. Microelement is iodine, fluorine, manganese, etc. Ultramicroelements, indium, gold, tellurium, niobium, and others. In the nature, water never meets chemical pure composition. Having property of universal solvent, it constantly has a plenty of various elements and compositions. The structure and which ratio is determined by conditions of water evaporation, structure of water burning horizons. The big influence of structure of natural waters, both superficial and underground, renders the man-caused pollution. Then we speak about water as about the reason of diseases, not infection nature. We have in view influence on human of chemical impurity, man causes of or anthropogeneous factors. The limit of a mineralization of drinking water, the dry rest, 1000 mg per liter, has been established on the basis of organoleptic sign. The basic part of dry rest of fresh water consists of chlorides and sulfates. These salts have expressed salt or beta test that is limited one of water up to level of a thiazole of sensation. 350 mg per liter for chlorides and 100 mg per liter for sulfates. It is established that the lower level of mineralization at which the homeostasis of the organism is supported by adaptive reaction, that the minimal content of calcium should be not less 25 mg per liter, magnesium 10 mg per liter. The water readily caused by the total contents of calcium and magnesium was considered usually in economic and domestic aspect. There is a direct high correlation of water regularity with the content in it, except for calcium and magnesium, more than 12 elements from any ounce lines. However, already for a long time there were assumptions about ecological role of the salts causing of water rigidity in development of urolithic illness. In other names is urolithiasis. On these slides you can see names of endemic diseases spreading by water waves. Firstly, you can see natural chemical composition, macronutrients and micronutrients. And you can see on the slides which diseases spreading by water waves. Endemic fluorosis, endemic gout, strontium rickets, molybdenum gout. Fluorosis is caused by high concentration of fluoride in the water, more than 2 mg per liter. Methemoglobinemia, you can see on the slides. The firstly on this is fluorosis. This methemoglobinemia is caused by high concentration of nitrates in the water. Endemic gout, as a result of iodine deficiency, the concentration of the iodine in the soil and water is low in the mountainous area. And molybdenum podagra. Molybdenum podagra is a result of molybdenum when concentration of molybdenum in water, in feeding products, in soil is very high, and on this slide you can see photos, pictures of endemic diseases. Long-term use of water with a low level of fluorine result in these caries. Its prevalence is extraordinarily high. Almost all population of developed industrial countries is affected by caries. If fluorine level in water is below 0.5 mg per liter, the prevalence of caries among population reach 50% and more. If fluorine level in water is above 3 mg per liter, the prevalence of caries is sharply decreased. However, the high concentration of fluoride in drinking water also results in pathologies. Long-term use of water with fluoride concentration 1.5 mg per liter and above leads to occurrence of another endemic pathology, fluorosis. You can see on this picture. More often, fluorosis is related with consumption of water from underground water source. Their fluoride concentration are 3 up to 5 mg per liter and above. Fluorosis is characterized by original mottling and brownish coloring of dental enamel. On enamel surface, symmetrical strips and spots with folic pigmentation are appeared. Then spots are increased, enamel gets a tawny or brown color. The endemic gout is also related to water chemical composition, low concentration of iodine. Endemic gout is diseases externally manifesting as increase of thyroid gland caused by hyperplasia of thyroid parenchymas. Pathogenesis of these diseases is rarely combined. The various disorders of thyroid gland functioning are in base of it. In several cases, the symptom complex is development. It is characterized by physical and mental retardation, and disorders of central nervous system. The network of connection is less dense. Always the water factor had a considerable role in occurrence of endemic water, but actually the daily need of iodine is basically covered by the food. The daily requirements of iodine makes 120 micrograms. So you can see that the endemic water mostly in the elementary diseases. The most sensitive group of population or indication group to iodine deficiency is the children of 7 up to 12 years living in the endemic areas. The biochemical profiles characterized by high concentration of molybdenum and low concentration of copper in environment. The population of this area has specific pathology related to purine exchange disorders, which was called as molybdenum podagra. The daily need of molybdenum for adults is 0.50 up to 0.3 milligram. The centralized water supply allows to lift a level of sanitary culture of the population, promotes reduction of diseases only as unilateral submersion of enough of water of the certain quality. A fragment of this of all the sanitary rules, as at the organization of water supply and during of use of water pipe lead to sanitary trouble down to accidents. The most mass and least heavy consequences of infringements of public health are connected to the opportunity of carry with water of pathogens of intestinal infection diseases. The opportunity of transfer through water of cholera, typhoid fever, salmonellosis, dysentery, brucellosis, virus of hepatitis, and other is provided. In water of water supply source, frequently we find out viruses of a poliomyelitis, viruses adenovirus, and enterovirus. Accordingly to the data of World Health Organization, annually in the world because of poor quality of drinking water dies about 5 million people. The infection diseases of the population connected to water supply reaches 500 million cases per day. It has given the basis to name a problem of water supply hygiene by a problem number 1, supply the good quality water inadequately, in order that distribution of infection diseases through water would become real. Simultaneous presence of this condition is necessary. The first condition, etiological agent of diseases should get in water of a source of water supply. At modern development of canalization of the occupied places, presence infection patients and healthy bacteria carry this condition constantly is present. The second condition, pathogenic microorganisms should keep vitality in the water during enough long time. The reality of this condition is determined by the ability of preservation of a microbe as biological kind. Practical supervision and experimental data testify about opportunity of their long existence outside of human organism, for example in the water. The third condition, etiological agents of infection diseases should get this drinking water in human organism. This condition can be realized a breakdown in progress process of water preparation technology at station of water treating of the first operation of a water supply system. On monitor you can see infection diseases spreading by waterways, intestinal diseases by bacterial origin, viral diseases, protozoal invasions, bacterial zoonosis, leptospirosis, intestinal helminthic invasions, and others. On this slide, you can see the role of water in the spread of parasitic diseases. You can see two types of these parasitic diseases is helminthiasis and biohelminthiasis. What is a helminthiasis? Is ascariasis, ankylostomatosis, strongyloidiasis. Biohelminthiasis is teniarianhos, teniasis, epistarchosis, trematodes, and others. On these slides, you can see scheme of sanitary chemical parameters of water pollution. Which main source of water pollution? We say about 4 main sources. First is industrial. What is industrial? Plants and fabric, emergency, mineral resource industry. The second is the communal domestic. It's economic households, dams. Transport is water transport, ground basis transport. And last is agricultural, animal husbandry, field husbandry, and others. On these slides, you can see scheme of water disinfection. Methods of water disinfection divided on 2 parts. 2 methods. One is physical method, the second is chemical methods. The basis method of improvement of cleaning water quality are clarification, decolorization, and disinfection. Clarification and decolorization of water are reached with the help of coagulation, sedimentation, and filtration. For disinfection of water are applied chemical and physical methods. For sedimentation are applied horizontal and vertical precipitation tank. Clarification depends on speed of water movement and densities of particle. The more slowly water flow and the more hardly the particle, the more easy they fall on a bottom about 1 meter up to 1 millimeter in the second. Speed in horizontal sediment balls 2-4 millimeter per second. In vertical 1 millimeter per second. Time of passage 4-8 hours. Lag is a slowness and increase in volume of precipitation tank for time lightening of sedimentation. Coagulation of water. The weighed substance from flakes and drop out in a deposit. Coagulant has a change opposite to a change of colored particles. Sulfate of aluminum is used for this. After coagulation are used precipitation. Water, gathered down part, is distributed and rises with a small speed at depth, passing through coagulant layer in a zone of clarification, the filter. The filtration is passage of water through fine porous material. Filters of slow speed contain clarifiers. Efficiency 95% in detention of suspensions. Consists of sand, level, gravel. In filters of new type, water passes through coarse drained layers and then through sand. Speed on filtration 4-5 meters per hour. One of the most widespread disinfection method is chlorination. To chlorination of water are applied gases chlorine, chloride, lime, dioxide of chlorine, hydrochlorine of calcium, chloramines. Chlorine-containing tablets are applied to disinfecting individual stocks of water, pentanticide, aquacept, etc. There are some ways of water chlorination. Chlorination by normal doses. You can see on the slides, normal chlorination. The dose of chlorine is established once on-site chlorine absorptivity and sanitary norm of residual chlorine. Second is chlorine with ammonization. In water simultaneously are entered chlorine and ammonia for chloramines formation and hyperchlorination. The dose of chlorine considerably exceeds water chlorine absorptivity quantity of active chlorine which is spent during chlorination 1 liter water during 30 minutes for oxidation of the organic substance, easily oxidized inorganic substance and connection with protoplasm or bacteria. For maintenance of reliability of disinfection, it is necessary that after end of process of chlorination in water, residual chlorine in the following quantities contained: 0.3 up to 0.5 mg per liter of free residual chlorine. At normal chlorination is 0.6 up to 1 mg per liter of the connected chlorine. At chlorination with ammonization. The necessary dose of chlorine at chlorination by normal doses is determined in each case by carry-out of test chlorination which account chlorine absorptivity of water. Minimal time of chlorine contact with water at chlorination by normal doses makes in the summer not less than 30 minutes. Time of contact increased up to 1 hour in the winter at low temperature. This one consists of stage A. Management of the equipment for liquid chlorine and plant for dissolution. B. Dosage of chlorine. C. Mixture with water. And D. Contact to water. Next is double chlorination before sedimentation and after the filter. Ammonization at once ammonia is entered in water and then chlorine in the ratio 1:4. Advantage a longer disinfecting action, prevention of smells and test of chlorine. Superchlorination is chlorination by superfluous doses of chlorine. Ozonation is applied in France, Switzerland, England, the USA, Kiev, Moscow. Advantage of this method: high speed. Ozone has not tested smell. Smell dependence from temperature, pH, and other properties of water. Ozone is made on a place. Special devices Ozonizers consist of two electrodes with an air layer between them, 2 or 3 millimeters, used for a discharge speed. Ozone is received from air, disinfected by UV beams. Speed, absence of a smell and taste, lacks. The test control over maintenance is excluded. Complexity of technical service. UV lamps are allocated above a water stream or into the water. It is applied on small water pipers. And now I bring to your attention an interesting video material about various disinfection methods that I have prepared. Please, you can see.
Clean water is constantly supplied to our taps, but the methods used to make our water safe to drink are rarely considered. However, without these methods, our lives would be very different. The problem is, clean water isn't available everywhere. Development and understanding of different water purification methods is key to ensuring that everyone will soon be able to access clean water, which is vital for survival. In this video, I will explain a method called chemical disinfection and how it plays its part in tackling biological contamination. This is when water is contaminated by microorganisms such as germs, viruses or bacteria which are harmful to humans. Chemical disinfection works by adding chlorine bleach or chlorine tablets to the water. Chlorine is called a halogen element and is found in group 7 of the periodic table. Halogen elements, such as chlorine, are very frequently used in water disinfection because their chemical properties mean that they can break down the cell wall of a microbe, which then causes it to die. This means that chlorine will successfully kill all of the pathogens most commonly found in natural water. The major benefits to this method of disinfection are that it is quick, cheap and very effective in removing biological contamination. However, a major downside to this method is that using an incorrect ratio of chlorine to water can have serious health effects on the consumer. Too much chlorine can cause problems with the liver and heart, whereas not enough chlorine can leave the water insufficiently decontaminated. This means the volume of water being decontaminated needs to be known before it is treated chemically. In industry, chemical disinfection plays a very important role in producing clean water. It is a method which I believe is one of the most viable to be used abroad to ensure those in developing countries have access to clean drinking water. Many don't realise it, but chemical disinfection plays a very important part of our lives every single day.
Disinfecting water with ozone. With proper treatment, drinking water can taste good even when drawn from rivers and urban areas. One treatment is advanced oxidation using high concentration ozone. Widely used in Japan, it's now being introduced in other countries too. Ozone is an important topic in discussions about global warming. Known by the symbol O3, ozone is formed when an extra oxygen atom binds to an oxygen molecule. When ozone is dissolved in water, its oxidizing properties disinfect the water, eliminating unpleasant tastes and odors. As ozone is made from oxygen, after use it reverts to pure oxygen and vanishes without a trace. Mitsubishi Electric's advanced ozone generation systems make river water drinkable and tasty. Ozone is generated by the silent electrical discharge method. This creates ozone by bombarding oxygen molecules with electrons. In conventional systems, some of the ozone created is broken down by electron bombardment. Research at Mitsubishi Electric has led to a reduction of the discharge gap, which minimizes the breakdown of ozone within the generator. Our ozone generators produce high concentration ozone at low operating costs. Water treated with ozone is delicious right from the tap. This is a benefit that everyone can live with.
In some cases, we use special methods of water purification. The traditional technology of water treating in water pipes possesses the limited area action concerning many chemical substances. Underground water very much frequently high mineralization also required a special clearing. We shall consider some from them. For example, fluorination, defluorination, deferrization, desalination, deactivation, and deodorization. What is a fluorination? Artificial action, addition of fluorine, speed and the maintenance of fluorine in water less than 0.7 mg per liter, with the purpose of preventive maintenance of carriers of a disease. Fluoridation of waters are reducing this disease carries on 50 up to 70% in 2 or 4 times. What is the defluorination of water? This method spans filtering through anion exchange filters. Frequently for this purpose use activated aluminum oxide. Sometimes for decrease in concentration of fluorine, spent dilution of water of other source not containing fluorine or containing it in the minute quantities. Desalination. Consecutive filtering of water all over again through cation resin and then through anion resin allows to release water from all salts dissolved of it. A thermal method, desalination, distillation, evaporation, with a subsequent consideration, freezing, and electrodialysis, desalination with use of selective membranes. And next is deodorization, elimination of smells. It is achieved by aeration, processing by oxidizers, ozonation, the big doses of chlorine, potassium permanganates, filtering through the activated coal. In end, I won't say about our conclusion. The doctor of the general practice should remember that 70% from all diseases in the world are connected to unsatisfactory quality of drinking water. The basic preventive actions are standardization of drinking water quality, use of modern system of water treating and methods of disinfecting, alternative to chlorination, application of various means of additional cleaning of water. Now, in word practice of drinking water, supply are widely applied water in bottles. Hasselholt filters no additional clearing water. Work which one is based on suction effect that allows to improve physical and organoleptic water property. Thank you for attention. Goodbye, student. Good luck.